Below are box plots of goals scored by players from two teams. We are supposed to make a conclusion as to which players from which team are really, really reliable to be featured in a match. Okay. When you are asked to actually compare data, the first thing you need to talk about is the median. The second is the interquartile range, and possibly use range where necessary to talk about the variability of the data. You talk about all the five automatically, because if you want to talk about the range, you are talking about the maximum and this minimum number. If you want to talk about the interquartile range, is the lower quartile and upper quartile that you are using to calculate. So it's simply much the same as talking about the whole thing. So let's see. You see that team B median is bigger than team A. What does it mean? We'll come to that in a minute. Also, team B's interquartile range, as you can see, is bigger than team A. Let's talk about the range. You can also see that the range of B is bigger than the range of A. So you can see every aspect that we see here: median, interquartile range, and range of B is bigger than A. Okay, so this is just a statement that we just made. Now let's see the implications or the contextual meaning of these. Whenever median is bigger, so in this case, team B's median is bigger than team A, that means that on average, players from team B score more goals than team A. On average, median is a type of average. So on average, the goals from team B are more than goals from team A. When you talk about the interquartile range, it means that the middle 50% of the data is more varied. So there's more variability in the data of the middle 50%. In that case, it means that it makes the median not reliable for team B. So whenever the interquartile range is too wide or too big, it makes the median not reliable. The smaller the interquartile range, the better is the median. So here we can say that team B's interquartile range is bigger than team A, and that means that the median for team B, though bigger than A, is not reliable. It's not really consistent with the data. But this median for team A is more consistent with the data. Also, the range of B is wider, meaning that the data in team B is more varied. The variability is wide in team B than team A. So it means that one day a player could score 1, the next day could score 7, the next day could score 2, the next day could score 8. It's so varied. But team A is more consistent in terms of the variability. So note, the bigger the interquartile range, it makes the median not consistent. So the smaller the interquartile range, the better and the more consistent is the median. The smaller than the interquartile range, the more consistent or better it is the median to represent the data. Now let's look at a situation where we have both median the same. So here you see boys median the same as girls, interquartile range for boys bigger than girls. Now if you want to explain, and range is boys bigger than girls. Now here, because they are the same, on average it seems to be performing or scoring the same marks on average. Now that's one of the reasons why we might need to use the interquartile range. The boys' interquartile range is bigger, making their median not consistent. So we can say that the median for girls is more consistent than the boys because the interquartile range is smaller. And there's more variability in the boys' data because the range is wide. So the data is more varied compared to the data of the girls. So the rule of thumb here is that the smaller the interquartile range, the better it is for the median to represent the data, or the more consistent it is for the median to represent the data.